Hey, how's it going? Okay, Leetcode 1930, unique length 3, palindromic sequences. Given a string S, return the number of unique palindromes of length 3 that are a subsequence of S. This should be an easy. Note that even if there are multiple ways to obtain the same sequence, it should still only be counted once. A palindrome, we know what a palindrome is. A subset, we know what a palindrome is. Can be deleted without changing the relative order. Oh, not a substring, a subsequence. Interesting. That is a little different. Okay, I agree. It should be a. I do agree that it should be. What the hell am I trying to say? A medium. So I think the first thing that we should do is we should convert each letter to a bit. And then we can calculate everything on the right and everything. Oh, God, that sounds like a big pain in the ass. And what's it going to do? Make it run a little faster. Okay. First thing I want you to do is ignore everything that I just said. Okay, left equals boom, right equals boom. None times length S. None times length S. All right. Okay, now I need to verify that if you add to a set, it doesn't modify the original set. So we'll say A equals set of 1, 2, 3, right? And then B equals A plus 4. You cannot do that. Unsupported operands of type. Set and set. You can't add two sets? What? What do you mean you can't add a set? All right. A dot union. Is that how you do it? B A. Okay. You can't add as you can subtract, but you can't add. That is so dumb. All right, so for I in range S, not range S, length of S. There we go. Length of S. Let's go like this. 1. Now, left of 0 equals set, right? And then right of -1 equals set. Okay, so we are at 1 and we are going to well, there can be nothing to the left, obviously. So, now, if S of I is in left of I minus 1, then left of I simply equals left of I minus 1. There's no reason to do anything to it. Otherwise, let's see, dot union of S of I. Right? And let's just start from scratch. -1 and then reversed. So we collect everything to the right, we collect everything to the left, and then everybody's happy. All right, so now what do we do? Well, it's exactly the same. If S of I is in right I plus 1, then we do nothing. Right of I equals right of I plus 1, because the union would be the same. And there's a memory overhead with needlessly copying a set. I'm kind of regretting not using bit fields, but whatever. Okay. Otherwise, dot union set of S of I. Right? Okay, and then we just need to know what all of the combinations are. And for that, we'll look at, well, it can't possibly be either of the end ones. So, so now we need a union set, sure, whatever, equals left of, not union, I meant intersection, right I, and then unique palindromes equals set, and we don't need to store the left and right, we only need to store one or the other. So for J in US, unique code equals J plus S of I, right? And we'll do up.add UC. That'll take care of the duplicates and return length of up. Okay, I agree that is a medium, so interesting. What did it think was valid? D, what in God's name? Oh. It thought D was to the right. Or left. Which is it? Right or left? Well, we'd better figure it out. Bettenturant we. Okay. Left of 1. Right of 1. Show me. Both? How? Right of... Oh, God. Forget wasted memory. I don't give a shit. Okay. So we're going to copy it. And then we're going to add it, right? So first thing we're going to do is left of I equals, can we do this? Left of I minus 1 dot copy. think that that's valid. Let's find out if it's valid. That is correct. That is correct. Well, it answered the question of whether or not copy is valid. Now, what we will do is we will say left of I dot add and then s of I minus 1. So we're going to resolve that problem entirely, and I don't care if there's a little bit of wasted memory. Dot add s of I plus 1. All right, it is passing. Let's try submitting. Ugh. That is really bad. Should I have done the bit thing? I should have done the bit thing, shouldn't I? All right, let's do the bit thing. I'm not happy about that. That is making me angry. So s equals ORD of I minus ORD of lowercase a plus 1. Well, no, probably not plus 1. For I in S. And that should make every one of them a unique bit. Now it should still run. Interesting. That shouldn't have changed the value. That is bizarre. These should just be numerical values here. Print left of 1, right of 1. Eight, 2, 4. Oh, it's adding them as numerals. Oh, God. Oh, for hell's sake. That is so dumb. That no. That's fine. That's fine. Just I don't know. that was kind of funny. Okay, mystery solved. Okay, now. All right. Now we're just going to say left equals left minus 1 bitwise OR of S of I. Right? Almost. S of I minus 1. Minus 1. And then this is going to be right bitwise OR S of I plus 1. Okay, and it should still be passing. Set and int. int object has no attribute intersection. That is correct. It doesn't. Bitwise and. Int object is not iterable. Well, how are we going to deal with that? UP equals set. Yes, it does. We need to differentiate the center from the outside one. So I think we're still going to use the set. So we will say no, let's not do it like that. Let's do it like this. Valids. I need to undo the bit shift. Let's do it like this. Yep, ORD of I, and then this will be I for I in SO, right? Okay. Then for each of these, we will say balance equals 0 times 26. And then we'll say for so valids for SO of I, because we have to choose a middle one, or equals US. Okay, and then it will simply be the sum of I dot bit count for I in valids. And that should be a little faster. Oh man, I thought we'd do better than that. Oh well, whatever. Anyway, see ya.